All right, in this video, we're going to talk about solving inequalities. And solving inequalities is very similar to solving equations. We can use inverse operations and properties of inequalities to solve them. So what we're going to establish here is something called the addition and subtraction property of inequalities. And that says that you can add or subtract the same amount from both sides of an inequality, and the inequality will remain true. So we're just going to very quickly test this property to see if it is true. So I have an obvious statement here. 3 is less than 8. And we are going to test this property by adding a positive number to both sides of this inequality to see if the inequality will still remain true. And I'm going to keep things easy here. I'm going to add a positive 2 to both sides of this inequality. And when I do that, I get 5 is less than 10. Is that true? Well, yes, that is true. So this property checks out for adding a positive to both sides. What if I subtract a positive number from both sides? What if I subtract a positive 2 from both sides? I get 1 is less than 6. Is that still true? Yes, that is still true. So we can add positives, we can subtract positives. What if I add a negative number to both sides? I'm going to add negative 2 to both sides, and I get 1 is less than 6. And that is true. So I can add a negative or I could subtract a negative. What if I subtract a negative 2 from both sides of this inequality? 3 minus negative 2 is 5, and 8 minus negative 2 is 10. 5 is still less than 10. That is true. So we have tested this with every type of number we could add or subtract to both sides of an inequality. So we have confirmed that the addition and subtraction property of inequalities is true, and we can have confidence that that will always be true. So we're going to use this property to solve these inequalities. So here I have y plus 10 has to be less than 3. So what are all the numbers that y could be where y plus 10 is less than 3? Well, we could guess and check, or we could just solve this like we would solve an equation. Now we're going to take 10 away from both sides here so that we can get rid of that constant that is on the left-hand side with our y variable, and then 10 minus 10 is 0, so I have y plus 0, which is y. And 3 minus 10 is negative 7, and there is our solution. Y is everything that is less than negative 7. So any number less than negative 7 will be a solution to this inequality. So you can test it if you want. So if you just pick a number less than negative 7, like negative 8, and plug that back in, negative 8 plus 10 is 2, and 2 is less than 3, so that checks out. So we tested something that is less than negative 7 and found that it is indeed a solution to that. Or we could pick something greater than negative 7 and see if it doesn't work. So if we pick negative 6, for example, and plug that in there, negative 6 plus 10 is 4. 4 is not less than 3, so negative 6 is not a solution, so this seems to check out. You see what we're getting at here? So we can find all the solutions right away, just solving these like we would solve an equation. Take a look at the next one. X plus 7 is greater than or equal to 10. So to solve this, we're going to get rid of this constant with our variable. We're going to subtract 7 from both sides of this inequality, and x is greater than or equal to 3 is our solution. So anything that is greater than or equal to 3 is a solution. So if I put 3 in this inequality, 3 plus 7 is 10, which makes the inequality true because it can be equal. Or if I pick something bigger than 3, like 4, 4 plus 7 is 11, which is greater than or equal to 10. So those solutions check out. A couple more. 3 is greater than or equal to g plus 7. So again, I want to get g alone, so I'm going to eliminate that constant by subtracting 7 from both sides. 3 minus 7 is negative 4, which is greater than g. So negative 4 is greater than g, greater than or equal to. Sorry, I missed my sign. Make sure you don't do that. Include that sign. Now, sometimes inequalities written this way with the variable on the right-hand side get a little bit confusing for students. So what we can do is we can actually turn this around, but make sure you flip that inequality symbol around. These mean the same thing. Negative 4 is greater than or equal to g, or g is less than or equal to negative 4. They mean the same thing. So you can write your solution either way here. Once you get it. The next one, b plus 5/7 is greater than 2. So again, I want to solve this. I want to get rid of that constant by taking away 5/7 from both sides of my inequality, and I get b is greater than 1 and 2/7. And there's my solution there. So solving inequalities by adding or subtracting, very straightforward and very similar to solving equations. Do inequalities have the multiplication and division properties? So we're going to test these much in the same way we did addition and subtraction. So we're going to start with an inequality that is obviously true, 8 is less than 12, and we're going to test it by multiplying and dividing all the possible types of numbers that we could. So we're going to multiply both sides of this inequality by a positive, and I'm going to pick 2 because that's easy to do. So 8 times 2 is 16, and 12 times 2 is 24. 16 is less than 24. That checks out. So it seems that we can multiply both sides of an inequality by a positive number, and it will still remain true. What if we divide by a positive? Well, I'm going to divide by a positive 2. And I get 4 is less than 6, and that's still true. 4 is less than 6, so we can divide both sides by a positive number. I'm going to multiply both sides by a negative. I'm going to multiply by negative 2. And 8 times negative 2 is negative 16. Negative 16 is less than negative 24. That is actually false. Negative 16 is not less than negative 24. So here we run into a problem. Negative 16 is actually greater than negative 24. That is the correct way to compare those numbers. So we cannot multiply both sides of an inequality by a negative number. Otherwise, we produce a false statement. Let's say we divide by a negative. If we divide both sides by a negative 2, we get negative 4 is less than negative 6, and that is false. Negative 4 is actually greater than negative 6. Now it's true. So this causes a problem when we're trying to solve inequalities by multiplying and dividing. Well, if we know that when we multiply or divide both sides of an inequality by a negative number, we can easily fix that by just swapping the inequality symbol. Turn the inequality symbol around, and then it magically becomes a true statement again. So that is something we're going to have to remember that's special with inequalities. The multiplication and division property of inequality says you can multiply or divide both sides of an inequality by any positive number, and it will remain true. However, this is the key take-home point right here. If you multiply or divide both sides of an inequality by a negative number, you must reverse the inequality symbol to make it true. That is only when you multiply or divide both sides of the inequality by a negative number. That doesn't mean if you ever see a negative number in an inequality, you switch the symbol around. But when you multiply or divide both sides of an inequality by a negative number, that inequality symbol must be reversed to keep it true. So let's look at some examples of solving inequalities here by multiplying and dividing. 5x is greater than or equal to 30. So this is multiplication. I'm going to solve this by division. I'm going to divide both sides by 5. 5x divided by 5 is just x, and 30 divided by 5 is 6. Now I'm not going to switch the inequality symbol around because I divided both sides of this inequality by a positive number. So this is my solution right here. X is greater than or equal to 6. So in case you are ever confused and you're not sure, pick a number that's greater than or equal to 6. Okay, 7. 5 times 7 is 35. 35 is greater than or equal to 30, so I know that that checks out, and I know that I did the right thing by not switching the inequality symbol. Next one, 19 is less than b divided by 8. The inverse operation here would be multiplication, so I'm going to multiply both sides by a positive number. So again, I am not going to be flipping my inequality symbol around. 19 times 8 is 152. So 152 is less than b. And again, we don't really like it when the variable is on the right-hand side. Sometimes that's confusing. You can always turn that around. B is greater than 152. So either way to write that solution is fine. Here, again, we see the negative y divided by 4 is less than 3. You'll see this written this way a lot, and sometimes it's confusing. Students aren't sure what to do with that negative when it's kind of out in the middle there. And we've said before, it can go either way. I'm just going to go ahead and associate that with the 4 in the denominator. So y divided by negative 4 is less than 3. So I'm going to multiply both sides by a negative 4 to solve this. And now you'll notice I did multiply both sides of this inequality by a negative number. So that means my inequality symbol is going to need to be reversed. So y is greater than negative 12. Y is everything that is greater than negative 12. So again, if you want to test that, pick something that's greater than negative 12 to see if it works. 0 is an easy number. 0 is greater than negative 12, and 0 divided by negative 4 is 0. 0 is less than 3, so that checks out. So make sure you check those if you're not sure. Next one, 7 is greater than or equal to negative 2f. I'm going to have to divide both sides of this inequality by a negative 2. And again, I'm dividing both sides by a negative number, so I know this inequality symbol needs to be reversed, and that is negative 3.5 is less than or equal to f. And again, we can flop that around. F is greater than or equal to negative 3.5. Either one of those is the solution. They both mean the same thing. Here we have two-step inequalities, or one two-step inequality that I'm going to solve. I'm going to solve this the same way I solve a two-step equation. I'm going to eliminate the constant by adding 18 to both sides. I don't have to worry about whether my inequality flips around because I'm just adding, and addition and subtraction never interfere with our inequality symbol. Negative 12 plus 18 is 6. 6 is greater than or equal to negative 3q, and negative 18 plus 18 is 0. And then one more step to get rid of that coefficient. I'm going to divide both sides by negative 3, and negative 2 is less than or equal to q. I did have to switch the symbol around because I divided both sides by a negative number. And again, we can write that with the variable on the left-hand side. Q is greater than or equal to negative 2. Either way to write that solution. And then finally, negative 2/3 g is less than 18. I'm going to have to solve this by dividing both sides by negative 2/3. And again, I'm dividing by a negative number, so that inequality symbol needs to be flipped around. And that gives me g is greater than negative 27. And there's my solution. So please, please, please make sure you're checking to see if you ever multiply or divide the inequality by a negative number. If so, that symbol needs to be switched around. That is the #1 mistake students make with inequalities.